Hi, everyone. I'm Winnie Chen, and this is my team, Annika Sundberg, Iris Dan, and Ayako Mikami. And we are the BrainLab. The BrainLab is your own personal neural network builder. We created this app because we thought neural networks are cool and useful, and they should be accessible to more people. Let's take you through a demo of our app. First, we need to upload a dataset. We accept CSV and text files that look like this. And today, we're going to train the computer to detect how Machiavellian you are by feeding in the data from a personality survey. So here you can select and deselect parts of your data to include in the input for your training. We assume that the output column is the last column of your data. Now we can start building our network. A neural network looks like this. It's got an input layer and output layer with hidden layers in between. Your data basically determines the input and output layers. We have 21 neurons for 21 questions. But the user can add and remove hidden layers and neurons to make up the structure of their network. We can start training when we're happy with our network.
Thank you, Winnie. Now our network is being trained by iterating through our sample sets many times, applying different weights, and ultimately saving the weights that give the highest accuracy. The graph here shows how our accuracy has progressed throughout the training. And in this case, our max accuracy is 96%, which is great. If the result is not good, you can still go back and adjust the number of hidden layers and neurons and try again. We hope to add more pre-processing features in the future to our app so that it can handle a wider variety of different data sets. This visualization shows you how our network has classified the outputs. So each of the big circles correspond to an output class, and the small dots are the samples. So if you click one sample, you can see information about the sample here at the bottom, the inputs, the predicted accuracy, as well as the actual accuracy, the actual output, sorry. And now since we're logged in, we can choose to name and save our model to our account. But even if we're not, we can sign up now and save our model. So here on our account page, you can see all the models that we've saved. And let's click on the model that we just trained.
Thank you, Annika. So this table shows 2 sample rows taken from the original user inputs. This way, even if you come back months from now, you still know exactly what the input columns were for your trained model. For testing, we have 2 options, single and multiple. If you have only 1 sample row to test, go to the Singles tab, type in the numbers, and press Submit. For multiple, you simply have to upload your data set, and a snippet of that will appear below for you to check. If it's all good, we can submit. And once the Python script runs the predictions and comes back, we display the result in this nice table with inputs and predicted outputs. And if the user wants to download this result, they can just download it in a CSV file, or they can test again. So that was the brief demo of our app. Now Ayako will walk you through the technologies.
Thank you, Iris. So now let's walk through what happens when a user clicks the train button. We make a post request to the train route and send an object that includes the input array, output array, number of hidden layers, and neurons. Node acts as a middleware. It spawns off a Python child process and sends information from the front end to Python. We're using Keras, a Python library, in order to build, train, and test our neural network. Since Keras only accepts a .h5 file for weights, in order to save the weights and configs, we put them in a separate file system instead of the database. For scalability, we'll be storing this on Amazon S3. After saving the weights, Python sends back the results of the training to Node. Node stores any information that needs to persist about the model into the database. Finally, Node sends back a response to the front end where the accuracy graph is shown. That concludes the explanation of our app. We are the BrainLab. Please visit us at brainlab.tech. Thank you for listening.